Hello everybody, I've been meaning to do this video for absolutely ages, proving Pythagoras. The reason being is because I often just say what it is, a squared plus b squared plus c squared, and I seldom take the time to explain it. And actually, it is a very powerful and easy to prove theorem, and Pythagoras goes from before GCSE, GCSE, A-level and beyond. So it's such an important theorem, it deserves to be shown, but it can be proven relatively easily. So let's get straight to it and prove this very, very famous theorem, which almost everyone will have heard at some point in their lives. So let's do it step by step. What we need to do is start with any old right-angled triangle, and what we're going to do is just label two angles. We're going to label the right angle in it and one other angle A. So this is a triangle I've picked. Could be any triangle as long as it's a right angle. So this one here, so we're going to label, obviously this one is a right angle, that's a square. This one here is going to be A. So I'm going to label this one A. And then what I want to do is to think of this one in terms of this right angle and this blue one I've called A. So angles in a triangle obviously add up to 180 degrees. So let's think about how we can work out what this mystery one is in terms of A and that right angle. So because all of the angles here, all three need to add up to 180, angles in a triangle add to 180, we can say that angle A plus a mystery question mark angle plus this 90-degree angle equals 180. What we can do now is get the question mark as a subject. If we take away 90 from both sides, we have A plus question mark equals 90. Then if we take away A from it to get question mark on its own, this mystery angle must be 90 minus A degrees. So I can replace the question mark with what it is in terms of A. So there we have it. That's step one. Moving on to step two. What we're going to do now is label the bottom side A, the vertical side going upwards B, and the hypotenuse as C. So we've got A, B, and C. Just add these on now. And we can now move further forward. Third step, we're going to now construct a square with sides A plus B using four clones, four identical versions of that triangle we've just had. And what I'm going to show you, if necessary, I'm going to convince you that we can make an inner shape that's also a square as well. So how you fit the shapes together is key. Those right angles need to be in the corner. Four corners made of those right angles. You need to make it like this. So those right angles in the corner, the blue angle is A, and that green angle I said is 90 minus A. I'm going to convince you now that these angles here, 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 and here are right angles because you need to know that this thing here is like a slanted square, it's a tilted square. And rather than me just telling you to believe me, I'm going to try and prove to you that this is a square. First of all the sides are the hypotenuses of these four identical triangles, but could it be a diamond or another shape where all the sides are the same apart from a square? For it to be a square, I need to show you these are 90 degrees. So let's remember what we know about angles on a straight line. Well, angles that are on the same side of a straight line, they actually add up to 180 degrees. So that angle A plus a question mark mystery angle plus 90 minus A, the blue plus that plus the green, should add up to 180 because here they make a straight line. Now I've got A plus question mark plus 90 minus A and minus A we can cancel off. A take away A leaves us with nothing. Then we can just work out what the question mark is by subtracting 90 from both sides of this equation. So this mystery angle will be 180 minus 90, which is 90, which is the definition of a right angle. So we can replace the question marks with right angles, and hopefully I've proven to you and convinced you this is a square in the middle. I'm going to colour code it yellow. Now these angles are getting in the way. It's a bit sort of confusing having these angles. We're not really interested at the angles at this point, so I'm going to remove them just so the diagram looks a bit simpler and less sort of busy. So I'm going to get rid of those and just keep that. Now let's think about the sides of this bigger overall big square that contains everything. This bit of it is A and that side is B. So side A joined to side B. The overall length of the bottom and the side and the top and the left hand side is therefore this A plus B. So that's the overall length of each side of the larger square, A plus B or B plus A. So the fourth step we can move on to now. Step 4, using this shape, we're going to form two separate expressions for the area of the entire shape in terms of a big outer square only, and then in terms of the 4 identical triangles, 1, 2, 3, 4, plus the inner yellow square. So I'm going to do this side by side. So first of all, in a red box, think about the big square only. Then in the blue box, we're going to think about the 4 triangles and the yellow square. So the overall shape, just in terms of this overall square, the big square contains everything. It contains the middle yellow one and 4 triangles. The area of a square is the base times the height. The base and the height are the same if it's a square. So the area of this overall big square is a plus b times by a plus b. So the area of the whole shape is a plus b times another a plus b, which is a plus b squared. I'm going to write that as a plus b times a plus b. Now, you need to be quite good at expanding brackets yourselves. So what we have here, a times a gives us a squared, a times b gives us ab, b times a gives us ba, which is another ab, then b times b gives us b squared. ab plus ab is 2ab, so we can neaten this up into simply a squared plus 2ab plus b squared. Thinking of the same overall area in terms of the 4 individual triangles now, plus this yellow square, we could also have said the area of the whole shape is actually 4 of them triangles plus that one slanted square. Now, the area of a triangle is half times base times height, which in our case is half times a times b. So we've got 4 of them both. So the area of triangle is going to be 4 lots of half times a times b, plus the area of this yellow square, c times c is c squared. 4 lots of a half is 2 wholes. So this can be replaced with 2 wholes. A times b is ab. So this whole thing here can become 2ab, then plus c squared. So we can think of the area of the whole shape as being this expression, or this one. Either or doesn't actually matter. But what we can say is this one must be equal to that one. So we can set these two as equal to each other. A squared plus 2ab plus b squared equals 2ab plus c squared. We can now, of course, remove the 2ab from both sides, basically cancel 2ab from both sides, and we can now see on the left we have a squared plus b squared, and the only thing left on the right is c squared. Therefore, we've nailed it. We've shown, therefore, a squared plus b squared equals c squared, which is the world famous result you will have known already, but might not have been proven to you until now. So there you have it, that's been proven. So finally, from me, I just need to say to you a fairly big thank you for listening to that. I hope that might have clarified any doubts. Your teachers have never lied to you, but hopefully it's proven that actually a squared plus b squared truly is c squared. So once again, thanks for listening. Hope you found it maybe interesting. If not, well, maybe the next one will be more interesting. Thank you anyway for joining me. I'll see you again all very soon.